Hey you. Yeah, you. I've got one question for you. How does one go about designing things using CAD or otherwise? If you want to know the answer to this question, then watch on and maybe you'll get some ideas. Welcome to 3C3D Academy's tutorial for design process. First off, we need to know what we're trying to design. So let's take a mechanical gripper as an example. Now let's ask ourselves some questions before we start to design. Questions such as, what type of objects does the gripper need to be able to grip? Are they hard like rocks? Or are they delicate like eggs? Are they slippery or are they rough? And how heavy are they? What shape should the gripper be able to grip? Are they all the same shape or are they different shapes? What we're doing here is we're trying to establish the goals that we want our design to achieve. And the last question there is especially important. It's easier to design for a specific case than for a general case. So if your gripper needs to be able to grip ping pong balls, for instance, then it's way easier to design a gripper that specifically holds ping pong balls and nothing else. And it's much harder to design a gripper that can grip anything and everything. Both of these grippers will be able to grip your ping pong ball, but one is much easier to design. So when you can, make the task easier on yourself by designing for a specific case rather than a general one. So we should keep this general rule in mind when we try and establish the goals of the design. And once we have established the goals, we're going to end up with a list something like this. So for our little example, the gripper should, number 1, be able to pick up, hold, and drop off ping pong balls without crushing them. Number 2, be small enough to fit into tight spaces. Number 3, be light enough for a robotic arm to move. And number 4, have a wrist to twist and turn around those tight corners. So once we have our list of requirements, we can start to think about the specifics of our design in the context of those requirements. So grab yourself a pencil, an eraser, and plenty of paper because this is part of the process where your design is going to take shape. Our next step is to brainstorm different ways of achieving our list of requirements. Like for example, number 1, the gripper can pick up balls with some fingers that move when we pull some strings. Or if we don't like that idea, number 2, the gripper can just be a vacuum nozzle that sucks and holds the ball to itself. Or number 3, the gripper can be a ping pong paddle covered in double stick tape, so the ball gets stuck to it, and that's how it holds it. So you might have noticed by now that each of these designs have their strengths. Like for example, the double-sided tape design is really easy to build, but they also have their weaknesses, like maybe it'll have trouble letting go of the ping pong ball. And the finger idea has no problem with releasing these ping pong balls, but it might be harder to build. And let's just be honest with ourselves, the vacuum gripper, that idea was just kind of dumb. Most of the ideas you have you'll end up not using, but oftentimes you'll end up combining some of your ideas too, like building a finger gripper that has sticky fingertips, for instance. So just keep in mind which materials you have access to and what equipment you have at your disposal. And once you've decided on an approach, you can start to worry about more specific things, such as what materials you have on hand or can purchase. So ladies and gentlemen, now's the time to jump into CAD and model the assembly. And the strength of CAD over paper sketches is that CAD allows you to visualize your object in 3D, exactly how it would look in real life. And this is super helpful because it helps you wrap your head around how it all works and how it all should move. Beyond that, if you find that you need to modify your design, you can do this so easily in CAD and still keep a copy of the original. Designing using CAD software is also very necessary if you want to use any sort of computer-guided machinery, such as a 3D printer, a CNC router, or laser cutting. Anything at all, really. And finally, CAD also allows you to easily share your designs with collaborators or with teachers when you're looking for their input. You can build prototypes or scale models of especially important or critical components and test them in the real world to work out their bugs before you waste a lot of time and money building the final revision. You may find that some of the steps we've covered here need to be repeated many times or that others are completely unnecessary for what you're doing. But this tutorial is a good all-around starting point for the mindset and methodology that professionals and hobbyists alike engage in when they design. So that's it for this tutorial. Check out our other design tutorials if you like, but until then, happy CADing!